All right, in this video, we want to talk about the number e as a limit. Previously, we stated that e had the property that the natural log of e was equal to 1. And now we're going to give two equivalent ways of writing e as a limit, and both are going to be incorporated later in the course. So the first limit we have is letting h approach 0. It's not the definition of the derivative, but here's what it is. And then the second is letting n approach infinity. Now, just to show you that both of these limits work, here's the value of e out to several decimal places. This first one, we're letting h approach 0, so if we start at 1, and you could see as we let h approach 0, it gets closer and closer to the actual value of e. For this other one, we're going to let n approach infinity. So if we start at 1, but multiply each one by 10, you can see that the value approaches the exact value of e there. So I want to prove the first one. So we start with letting f of x equal natural log x. Now this might seem weird, but you'll see where we're going here. So f prime is 1 over x, and f prime of 1 equals 1. Then if we work backwards and use the limit definition of the derivative with 1, so f prime of 1 is, and then with the functions plugged in, we would have, and then we could factor an h out of the denominator and rewrite it as, and then using the power properties for logs, we can write the 1 over h as the exponent. And then we know that that equals 1 because that is just the definition of the derivative rewritten, and we know that the derivative is equal to 1. Also, since the natural log of e equals 1, we're going to substitute that in for 1 right here. So then we'd have, I also used the property that if you take the limit of a natural log, like right here, you could take the natural log of the limit. So I just rewrote it like that. Since y equals natural log x is a one-to-one function, and we took the log of both sides here essentially, we could undo that, and turns out that the limit is equal to e. There we go. Now, you don't have to know the proof for the AP exam. I just think it's a pretty neat exercise to see where it came from. Now, let's look at two limits where we want to express each number in terms of e. The first one looks very, very close to the first limit definition, and with some manipulation, it can be expressed like that. So if we take the expression and rewrite the exponent as, now, let me tell you how we did that there. If we look at the original exponent, it's 1 over h. All I did was multiply by 2 over 2, and then write that as 1 over 2h times 2. And then the power on a power property, you could rewrite it as the quantity squared. So as h approaches 0, then 2h approaches 0, and we could let k equal 2h. So as h approaches 0, k approaches 0. And the reason we did that is we just want to rewrite the 2h in terms of k. So this limit would become, which looks very, very close to the original e definition of the limit that we looked at, but it's being squared. And there's a property that if you are taking the limit of a function squared, you can square the limit of the function, meaning this. The limit is equal to e, you're squaring the limit, so it's e squared. That's what we have. All right, now it's time to look at part B, and this is n approaching infinity. So this is the second limit definition. So we'll take the argument of 1 plus 3 over n to the 2n and try to manipulate it to make it look like the 1 plus 1 over n to the n. First thing we'll do is we need to account for the fact that there is a 3 here, and so we need to introduce a 3 in the exponent to make the exponent match. So if the exponent is 2n, then we're going to multiply that by 3 over 3. So this is going to be, and then we can manipulate that to rewrite the 2n to the 3 over 3 power. So basically I factored out the 2 and then distributed the 1/3 into the exponent. Then in this case, we're going to let k equal 3 over n. And as n approaches infinity, k is going to approach 0. However, if we take that k equals 3 over n and solve it for n, then n equals 3 over k. And same thing, as k approaches infinity, then n is going to approach 0. So we'll rewrite this limit and then again, since we're taking the limit of a quantity to a power, we can take the power of the limit of the quantity. And then this limit right here is equal to e. And that limit is raised to the 6th power, so our answer is e to the 6th. So it's all about algebraically manipulating these. So that's it for the number e as a limit. Hope that was helpful to you. Let me know in the comments if it was, and make sure you like and subscribe to the channel.